Hello my friends, I welcome you all to my YouTube channel CosmiKodes. Today we are going to learn how to design a PCB using the EasyEDA software. So I have downloaded the EasyEDA software and I am using it for a long time, and I found it very easy and very useful. So first thing, you need to go to the file, then new, then project. Here I will name my new project Blink LED. Now I will save it. Now you can see this is the working area where you can design your own PCB or schematic. Specifically, we can design the schematic here. So what I am going to do today is I'm going to use the CD4047 square wave generator IC, and I'll search for it in the library, and you can see here is the deep version DIP. So I'll select it by double clicking it, then I'll place it here. Then I'll need to go to the uh, commonly library. Here you can find the VCC as well as the ground I'll place the ground here. Okay, now the circuit diagram is like this. Pin number 456 goes to, and pin number 456 and 14 goes to VCC. Pin number 7 goes to ground. Pin number 8 goes to ground. Pin number 12 goes to ground. Now I will need one potentiometer and one capacitor. The capacitor will go from pin number 1 to pin number 2, and the potentiometer will also go from pin number 1 to pin number 2, and the whip is connected to pin number 3, for which I am using a net port. Now this net port, I will rename this as P3, meaning pin 3. Now I'll copy this net port and paste it on the pin number 3. So this means that our pin number 3 is connected to this whip of this potentiometer. Now I will change this capacitor value to 220 nanofarad, and I'll change this. I'll delete this one, and this RP1 I'll rename it to 10K. Okay, so our circuit is almost complete. Now for indication, I'll need two LEDs. One is green and one is red. Sorry, one is red, and I'll need another one, blue. Okay, now I'll need three current limiting resistances. I think 1K will be sufficient. I'll connect these LEDs in series with the resistances. Then I'll require three separate grounds. Okay, now I will use pin number 9 will also go to ground. Now pin number 10 will go to this red LED. Pin number 11 will go to this green LED, and pin number 13 will go to the blue LED. Sorry. Now I'm going to delete these texts. So our circuit is almost complete. Now what is needed is this VCC, this ground, and a decoupling capacitor whose value will be 100 nanofarad. I'll connect the capacitor and I'll require one connector. I'll use space to rotate the component and I'll place it here. I'll delete this one and rename this thing to power, meaning power. So our circuit schematic is complete. Now let's go to the, now I'll save it, after which I'll go to convert schematic to PCB from the design section, and you see, let's apply. Now I'll place all the components one by one. This is the tricky part of a PCB design, and this is the critical part where you have to be very patient, and you have to decide where you will put your components so that the routing becomes easy. This LEDs, now I'll place this LED. You can also spread the LEDs by clicking this icon, this distribute horizontally, so the distance between the three LEDs will be same. Now I'll place the resistance here, the next resistance, sorry, and the third one. So I think our PCB is almost ready. I'll squeeze the board size because I do not require this much of space. Okay, now you see, I'll rearrange the text, this silk layer, and I'll rename it to 2Q, Q dash, and Q. So these are the three outputs, and the next thing is I'll change this text position. So I think we're done. The last thing is needed. We have to select the top silk layer, then to this text, and I'll place it here. Then I'll reduce the size and I'll rename it to plus. I'll copy it and paste it. Then I'll rename this to minus. Okay. So now I'll save this and I'll go to Autoroute option. I'll unselect the top layer and I'll go to design rule. Here I can specify the track width, so I'll make it 0.8 millimeters and the track clearance will be 0.25 millimeters. Now I'll run it. As this is a very simple circuit, so the routing doesn't took much time. Now I will rearrange these tracks, these traces manually, so that everything is okay. So I'll clear these paths a little bit. The last thing that I want to do is to increase the stability of the circuit by placing a in the copper pore. So I'll select this copper area, and I'll select ground from here, and I'll select OK. After which we have to select the bottom layer, because our copper pore is going to fill the bottom layer. So I'll select the whole board, and after that I'll right click it, and you see our the unused area of the PCB has been filled with copper. Now I'll go to copper area manager. Here I'll increase the clearance of the copper pore to 0.45 millimeters, and our PCB is almost done. So you can see now I'll save it, and I'll go to fabrication. Oh, one second, let me have a look at the 3D model of it, which is a cool feature of EasyEDA. You can see that the PCB look like something like this, all the components is shown in here. So I'll close it. Next I'll go to fabrication, then PCB fabrication file, no generate garbar, then generate garbar. Here you can select the folder where you want to save your Gerber file, then I'll click next. Now you can also export the file as PDF or SVG or PNG. So I'll select PNG, or you can select PDF also. First we need to print the top silk layer. So I'll select top silk layer, board outline, multi-layer and whole, and I'll export it, and I'll select black on white, then I'll select export, and it will save the top layer. Then I'll go to export again, then PDF, then I'll unselect the top layer and top silk layer, and I'll select bottom layer. So this will generate the bottom layer PDF. Next we'll go to export and PDF again, then I'll select white on black, and I'll unselect these two, and I'll select bottom solder mask layer, and I'll export. So friends, as you can see, the three files have been created. The first one is the top silk layer, the second one is the bottom layer, and the third one is the bottom solder mask layer. These three PCBs are needed, these three files are needed needed to give to the manufacturer, and they will provide you with the PCB. Also you can send the PCB manufacturer this Gerber file, and through this Gerber file it is also possible to uh, manufacture the PCB. So that's it for today, friends. We'll see you next time. Please, if you like this video, please give it a thumbs up, and we'll see you next time. Thank you.